Alrighty, we are doing compound inequalities. It's not bad. You can take any compound inequality, and write it as two separate single inequalities, and then you just have to I guess the tricky part is figure out whether you're putting the two areas together or you're looking for the intersection. I'll show you what we're talking about in just a minute. All right, number one, we got 2 is greater than y plus 2, which is also greater than 0. Sounds weird, but I'm going to go with it. So I get 2 is greater than y plus 2, and y plus 2 is greater than 0. I guess I could solve that as not breaking up into two inequalities. You could solve it that way. It's not too bad, but I feel like there's a good basic way of doing it. So when I subtract 2, this will be 0. When I subtract 2, this will be negative 2. Let's see, we want to graph our solution set. So here's negative 2, here's 0. On this one, we want y values that are less than 0. All right, this way looks weird. Y values less than 0. Okay, so that direction. And we want y values that are greater than or equal to negative 2. So we want this direction. And this is an end statement, so it's a conjunction versus a disjunction. So we want the things that intersect, the things that share. So we basically want all numbers between negative 2 and 0. If I wanted to write it as a compound inequality, I'd write y is in between 0 and, y is in between negative 2 and 0. As an interval notation, we want to include the negative 2 and we want to go to 0. All right, moving on. Number 2, I think this one I'm just going to solve in the compounded form, I think they're called. Putting things together. Minus 2 from each side, minus 2, minus 2, minus 2. It's really two separate equations, but I'm solving it as one. Negative 3 is less than or equal to 3x, which is less than or equal to 6. Divide everything by 3. I get negative 1 is less than or equal to x, which is less than or equal to 2. I guess I'm graphing. Graph. So this is negative 1. This is 2. Again, this is my conjunction. These are filled in. Interval notation, I'm going from negative 1 to 2. Boom, done. On to 3. 3k, so this is the disjunction. We're using the or. Either set's going to work. Or 2k minus 3 is greater than 1. Solve this, so this would be 3k is less than negative 6. Or, I don't know, 3k, I'll finish this one. 3k is less than negative 2. I got 2k is greater than 4. I got k is greater than 2. So on the number line, I'm going to show my graph. Negative 2 is here. I'm going less than. It's an open hole. Here's 2, open hole, greater than. And so my interval notation is negative infinity to negative 2, union 2 to infinity, excluding all the values. You can't be infinity, you can't be 2. Anyways, ultimately, and I guess this is a generalization, but so it's not true all the time, but ultimately it's like our disjunctions look kind of like this. They go to the outside, and our conjunctions are the things on the inside. There's going to be some exceptions, but generally speaking, that's what it's going to look like. All right, so 4 still looks like a disjunction. 2x plus 3 is greater than 1, or 5x minus 9 is less than or equal to 6. Solving this, I get 2x is greater than, I feel like I should check answers, just in case. Negative 2x is greater than negative 1. I get 5x is less than or equal to, I believe that's 15. And I get x is less than or equal to 3. Oh, interesting. Yeah, so this is a good example. I like this problem. And the reason why is, like, if I were to draw this, if I were to draw this, here's -1. My graph would look, everything in this direction. And then here is x equals 3. And then my graph would look like, everything in this direction. Now, the problem is this thing's a disjunction. So we put together both solution sets. Now, a conjunction, you would just look where they intersect, where they both occur. But this is a disjunction. So we're actually adding the two solution sets together. Hold on one second. Okay, anyways, since this is an OR statement disjunction, we're really hitting any value. I mean, like, look at our graph. So this is like all values. This is going to be our, -infinity to infinity as our answer. I might just double check the answer key. Make sure we're good. 4, yeah, good job. All right. Number 5. Assuming the answer key's right. I don't know. Like, sometimes I trust ChatGPT and sometimes I don't. Yeah, don't know about that guy. It's getting better, I think. And 5x minus 9 is less than or equal to 6, I believe. And then drawing this, I get 2x is greater than -2, x is greater than -1. Let's see, 5x is less. I feel like I'm doing the same problem. Did they copy the problem? One's a conjunction, one's a disjunction. Okay, I think they're just trying to show you, what's the difference. So this is the exact same problem. It's the same answer. But if we were to graph this, like we're like, here's me graphing it, -1 and 3. This guy here would be like this solution, and this guy here would be this solution. But now it's an and, so it has to be in both sets. It has to be in this set and the other set. And so it's basically all the values between -1 and 3. So -1 and 3. Checking the answer key. 5, -1 and 3. Perfect. All right, 6. Moved along. Man, I don't know why they write these inequalities this way. I don't know. They're trying to like troll you or something. It looks really weird. I prefer my inequalities written left to right, so that the smallest number's on the left. But I'm just going to go with it. Whatever. Am I going to do this as a single inequality? You know what I am? I'm not going to break this into 2. So I'm going to subtract 1. I'm just going to be careful, though. And this will turn into 2, which is greater than or equal to -n/2, which is greater than -3, if I did that correctly. I multiply both sides by 2. I get 4 is greater than or equal to -n, which is greater than -6. And then when I divide both sides by -1, and that's what I'm going to do here, I'm going to have to flip the inequality. So, and I guess that's why they wrote it this way. I'm not really sure. When I divide by the 4 by the -1, that turns into -4, which is less than or equal to n, which is less than 6 when I divide by -1. On the graph, this is from -4 to 6. All values in between, bubbling that one, opening this one, and this is the interval from -4 to 6. Checking the answer key. -4 to 6 is good. All right, 7. Moving along. I mean, we're making some good time. We're kind of halfway through. But we'll see. There's a word problem, I think. All right, so 5n minus 1 is greater than 0. And 4n plus 2 is less than 0. All right, so this is 5n is greater than 1. And n is greater than 1/5? 1/5? I don't remember any fractions on the answer. All right, so this one will be subtract. So 4n is less than -2. And n is less than -1/2. All right, let's graph this. I'm having some current concerns with this problem. So here's -1/2, and here is 1/5. And this guy is less than -1/2, so we're going in this direction. And this is greater than 1/5, so this is going in this direction. So if you look at it, there's nothing in the middle. Like, I mean, there's no set they're sharing. It's an and, it's a conjunction. What's happening in this set and that set at the same time. So therefore, this is no solution. If you want, there's a few ways to describe no solution. You'll see like this. That's called the null set, or like this with braces. That's called the null set. And there's nothing in there. Let's see what the key has. 7. Yep, there's just empty brackets. Braces? But that's set builder notation. I'm not sure what empty set is for interval notation. Don't know. I'll have to look that one up. All right. 8. I think we're on 8. Okay, 8. Well, this one looks confusing. All right, this one you're gonna have to break up into 2 separate inequalities. I don't see us doing it just as like one compound inequality, but it could be wrong. And they still have the inequalities wrong, but it doesn't matter. Whatever. So I got 3y plus 5 is greater than or equal to 2y plus 1. And I got 2y plus 1 is greater than y minus 1. And then just solve each one. I'm going to get the y's on the same side and the 5 on the other. So when I subtract both sides by 2y, I get y greater than or equal to. When I subtract the 5 from both sides, that should turn into -4. Over here, again, I'm going to bring the y over, so that turns into y. And then I'll bring the 1 over, and that turns into -2. Interesting. Now this is an and. This is a conjunction. Interesting. This doesn't look fun. All right, here we go. So here's -4. I feel like I did something wrong. It looks good. Here's -4. Here's -2. So -4 looks like this, and 2 looks like that. So for it to be a conjunction, it has to be in both sets. So what's greater than -4 and at the same time greater than -2? Well, it's going to be all these values. So that's going to be from -2 to infinity. I'm checking the key on there. Yep, that's correct. 9. Okay, key's been pretty good. Go ChatGPT. -5 is less than 2 times 2 minus s. Ugh, my s's look terrible. I'm going to go with it. 9. I think I'm going to keep this in like the regular compound. I'm going to subtract 1 from everything. So this will be -6 is less than 2 times 2 minus s, which is less than or equal to 8. I'll divide everything by 2. -3 is less than 2 minus s, which is less than or equal to, excuse me guys, 4. Perfect. Subtract 2 from everything. -5 is less than -s, which is less than or equal to 2. I feel like I'm messing up. Double check. No, we're good. Divide everything by -1, so I get 5 is greater than s, which is greater than or equal to -2. What is that on the number line? Well, s has to be greater than -2 and at the same time less than 5. So if I had to guess, it's going to look like that. No big deal. On interval notation, this is -2 to 5. Moving along. Kind of on the back end here of these problems. All right, so 10. Looks like a 20-minute video. We'll see. Maybe these word prompts become really hard. -2s plus 1. All right, so that or 1 is less than 2s minus 1 is less than 5. Okay, this is kind of tricky because it combines, wow, and this is also less than 5, sorry. It's interesting. I don't know what I'm thinking about this problem, but this is challenging because it's a conjunction and a disjunction at the same time. So I'm going to solve each conjunction first. So I'm going to do some side work here. Am I going to change up the color? Let's see, maybe. Okay, fine. I have 1 is less than negative 2s plus 1, and this is less than 5. Divide both sides by negative, so I'll get negative 1 is less than 2s plus 1. Actually, divide by negative, we're going to switch the inequalities. This is going to be greater than, negative 5. Subtract negative 1 from both sides. So there's going to be negative 2 is greater than s. I'm sorry, 2s. Gosh, I can't think for some reason. Again, subtracting negative 1 from all three sides. And then finally dividing by 2. So I get negative 1 is greater than s, and at the same time s is greater than negative 3. Or if I want, and I like to prefer to write this left to right, this really means negative 3 is this s, which is this negative 1. So it's somewhere between negative 3 and negative 1. So it's this solution set. Okay, that's our first one. Now we're going to go solve the second one. Do I have a third color? Let's see if I can do that. What color is this? I don't like that. I'll just go back to blue. All right, so then over here we'll have 1 is less than 2s minus 1, which is less than 5. Solving this, I'll get 2 is less than 2s, which is less than 6. Divide everything by 2, I get 1 is less than s, which is less than 3. All right, and then I get the solution. S is somewhere between 1 and 3. So I guess it's not filled in. So if you think about it, my answer is the union of these two things. So my answer should be, final answer, should be negative 3 comma negative 1, union 1 to 3 as my answer. I'm going to double check the solution key, make sure we're good. Looks good. Looks good. 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 Nice, ChatGPT. You're doing well on the solutions. 11 says find all sets of 3 consecutive even integers whose sum is between 25 and 45. Again, you could just like pick integers that are consecutive, like 4, 5, and 6. This doesn't work, but I'm just saying that you could pick them. You could like just guess and check. This is too small. This turns out to be 15. We want to be 25, so maybe like, I don't know, 9, 10, 11. This looks like 30. I mean, that works, right? Man, I think there's going to be a lot of these. Maybe too many. Maybe too many. I think 10, 11, 12 would work. This is 33. And so on. There's going to be a bunch of them, it looks like. But we're going to do this with algebra. Give this a try, see if we can do it. One thing, I guess, let me write this back real quick. So this was 4, 5, and 6. One thing that we should notice, right? To get to a consecutive, my bad. It says consecutive even integers. So not 4, 5, 6. It'd have to be like 4, 6, and 8 consecutive even integers. This one doesn't work. Maybe 8, 10, and 12. I believe this one works. This would give you 30, so this definitely works. But if you notice, I want to do this algebraically. So let's just assume, like, let x be the first integer. So here's x. We don't know what that number is, but it's just x. And to get to the next number, so if we start at 4, to get to the next even integer, you have to add 2. So the next one would be x plus 2. And to go from 6 to 8, we have to add another 2. So if we add another 2 to the expression, the next one's going to be x plus 4. So our first even integer is x, our second one is x plus 2, and our last one's x plus 4. So we have the equation, x plus 2 plus x plus 4, and we want this somewhere in between 45 and 25. That's what we want. And then we just solve this. So we get 25 is less than 3x plus 6, which is less than 45. And then we're going to solve this whole thing. So we like minus 6, minus 6, minus 6. Is that 19? Is this 19? I guess. So 19 is less than 3x, which is less than 39. Man, that 19 is really bothering me. Not triggering me, but it's like, it doesn't work out nicely. So divide everything by 3, so we get 19 1/3 is less than x, which is less than 13. So provided that x is in between 19 thirds, which is a little bit greater than 6, but less than 7. So as long as x is between 7 and 13, meaning obviously 7 is not going to work because that's an even integer, because we want even integer. One set would be 8, 10, and 12. And again, as long as x is less than 13. So another set would be 10, 12, and 14. Another even set would be 12, 14, and 16. Does that work? I don't even know if that works. Let me check. I think I messed up. Oh, is it between 45? No, we're good. That's 26 plus 16, which turns out to be 42. That works. So these are our 3 solutions that would work. Let's see if we get those. 8, 10, 12, 10, 12, 14, and 12, 14, 16. Perfect. My last question. So this is problem number 12. The 3 sides of an equilateral triangle are increased by 20. Okay, so we have an equilateral triangle. So x, and x, it's equilateral. And we're increasing the sides by 20, 30, and 40. The perimeter of the resulting triangle is in between twice and 3 times perimeter. Okay, so the perimeter of the original problem, the perimeter of the original problem is 3x. X plus x plus x. The perimeter of the new problem, so remember we're adding 20 to one side, so that would be the length of one of the sides. We're adding 30 to another side, so this would be the length of another side. So this would be like x plus 20, this would be x plus 30, and this would be x plus 40. And to find the perimeter, we add them all up. And then it basically says, our new perimeter, man, this is going to be really hard. Our new perimeter is somewhere between twice and 3 times the original perimeter. So, man, I like this problem. I do. It's challenging. 2x is somewhere in between these, so we'll say 3x. So we have this like crazy equation, and the question is, how are we going to solve this? So 3x plus, let's see, 20, 30, that's 90, I think. 90 is less than 3x. Ooh, I messed up. Twice, I messed up. This should have been twice the original perimeter. If the original perimeter was 3x, this is going to be 6x. This is 6x. If the original perimeter was 3x, this is actually going to be 9x 3 times. So I'm between 2 and 3 times. Okay, I got to solve this, but it does not look fun. I'm going to try my best, though. Give it my best. Yes. How do I do this? Well, I would probably separate this into 2 equations. 3x plus 90. And this is a conjunction. So this is 3x plus 90 is less than 9x. And then I'll solve each equation. So I'll move over the 3x. That'll turn into 3x is less than 90. And I'll divide by 3, I get x is less than 30. If I did this correctly, I think I'm doing it wrong. Let me double check. No, that looks good. At the same time, I guess I'm going to move this guy over here. So I get 90 is less than 6x. I want to like flip this because it feels more comfortable to me. 6x is greater than 90. And then unfortunately I have to do some math here, some basic arithmetic. This is 90 over 6, which is, if you divide by 3 in the numerator and denominator, this should be, actually 6 goes into 90, I think. 15 times? Let's see, 6 goes into 90. 1, this is 6, this is 3, yep, 15 times. So basically on a number line, if I were to look at the solution, and this is an and, this is a conjunction, and, so here is, I guess this is 15, right? 15. Here's 15. Here's 30. So x is somewhere between 15 and 30. What can you conclude about the length of a side of the original? Yep, it's somewhere between 15 and 30. Yep, perfect. That's our answer. Awesome, thank you. Man, that took a while. The last two were kind of not good. Again, on average, homework should be taking 20 minutes. Thank you.